When we first study systems of equations back in Algebra 1, we look at where two lines intersect. So we can see on a graph where two lines or graphs intersect. And then we looked at two algebraic methods before we started doing matrices as to where our two lines intersected. Do you remember the two algebraic methods we looked at to find where two lines intersect? What do you think? Elimination and substitution. So we're going to revisit all three of these ways. We're going to graphically look at where these two lines intersect, these two relations intersect, and algebraically we're going to look at where they intersect. By the way, if I just look at this cover page here, what type of conic is this? First one. It's a hyperbola. And I know it's a hyperbola because my b value is negative. And it's a hyperbola that opens along the x-axis, right? What is my second type of conic here? It's an ellipse because I've got two positive signs. All right, so I'm just going to, without really plugging in the numbers, I just want to show you if you've got a hyperbola and an ellipse, they could maybe never intersect. They could maybe intersect, let's say one time. If it just hit right there, they could intersect one time. This could maybe intersect, let's see if we do this. They could intersect, well, there's three times. They could intersect, if I hit this vertex and this vertex, they could intersect twice. And they could maybe intersect even 4 times. So my options for when I'm solving these is I might have 0 solutions. I might have 1, 2, 3, in this case 4 solutions. So I just want you to be prepared for multiple solutions. So let's look at this very first system. And the first equation in this system is what kind of a conic? It's a parabola. What do you know about this parabola? What are some of the key characteristics of this parabola? It opens which direction? It opens to the right. What about the vertex? What would be the vertex of this parabola? It would be -3, 0, right? Because this is my h value here, and my k value is inside the parentheses. So I'm going to plot that point, -3, 0. 1, 2, 3. It's opening to the right. And the a value is 1/2. So I think about that counting scheme that we learned way back in the first semester. If I square 1, I get 1. So I'm going to go over 1, and then half of 1, then I have to go up half of 1. So over 1, up half of 1. What about if I square 2? If I square 2, I get 4, and I multiply that 4 by 1/2. So over 2, up 2, over 1, 2, up 1, 2. What if I did, well, what if I did over 4? 4 squared is 16, and half of 16 is 8. So if I go 1, 2, 3, 4, I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Here, 1, 2, 3, 4. Here's its. There we go. There's my sideways parabola. All right. What about the second equation? What type of relation or function is this second equation? Right here. Well, let me tell you this. It's not a conic. Yes, sir. It's a linear equation. Good job. It's a linear equation. There's no quantity squareds here. So if I rewrote this, I could move the y to the left and the x to the right. And there is a nice linear equation that we learned how to graph in Algebra 1. We learned that the y-intercept was -3. 1, 2, 3. And I have a slope of -1. So up 1, left 1, up 1, left 1, up 1, left 1. All right. And then the best I can, if I had a nice ruler, that would be helpful for this, because it's linear. Not that all of them are going to be linear. And yeah, it looks like These two graphs are intersecting twice. Oops, let me do this. Thank you. Properties, I'll make that green, make it easy to see. All right, so it looks like I have a point of intersection right here and a point of intersection right there. So when we write our solutions, we're going to write them as ordered pairs. So I have one ordered pair at -3, 0, and I have another ordered pair at -1, -2. So these are pretty straightforward. Conics and maybe something else that we've graphed all year. You're going to have 4 of those to practice tonight. Those will be nice. And so then let's take a look at further down. I think my problems are a little bit different than yours. But I would like for you to, and if you want to add it to the back or on a separate page, I do want us to do this first one together, the one that I have up there. Okay, I have x squared plus y squared minus 13 equals 0. We'll do the one that's missing on your paper in a minute. And 6x squared minus y squared minus 15 equals 0. So if I say the word substitution or elimination, can you venture to guess what this is geared for? Elimination. Okay, and the reason this one's geared for elimination is because I have a positive y squared and a negative y squared right there lined up on top of each other. All right, so if we do the elimination method here, this is where we added the equations together. 7x squared minus 28 equals 0. If I'm going to solve this, I'd factor out my 7 and I'd get x squared minus 4 equals 0. The 7 doesn't help me with the solving. I just take care of this quadratic. So I've got x plus 2x minus 2 equals 0. So I have one answer with a -2 in it and one answer with a +2 in it. So I've solved for x. But remember, my goal is to find the point of intersection. That's the point has an x and a y coordinate. So now I'm going to go back up to either one of those equations, and I'm going to substitute the 2, and I need to substitute the -2 to find my y coordinate. All right, so do you guys want to use the first equation or the second equation? I'd use the first equation as well. So I'm going to have x squared plus y squared minus 13 equals 0. And first I'm going to plug in my +2. All right, so this gives me 4 plus y squared minus 13 equals 0. Or y squared minus 9 equals 0. So this factors to y plus 3 and y minus 3. So y equals -3 and y equals +3. So both of these answers, so let me write, so I have, when x was 2, I got a +3 and I got a -3. So that took care of this one here. So if I were to come back through, and now I'm going to use this one here, I'm going to put a negative there, what's going to change? Nothing. So my other answers will be -2, 3, and -2, -3. So I've got 4 solutions. Now, if you would like to write this a little more succinctly, you could say plus and minus 2, comma, plus and minus -3. Or you can write them all out. Either one is fine with me. All right, but know that there are 4 solutions. If I look at, if I had graphed, it looks like I've got a circle and I have a hyperbola. So my circle and my hyperbola are intersecting 4 times. Okay? So let's take a look at what you have next on your paper. So let's do your letter B. Okay, and then we'll come back and do C. So on your paper for letter B, you have x plus 5 quantity squared and y minus 2 quantity squared equals 15. By the way, what is this conic right here? It's a circle. And then what do I have here? What is this type of conic? It's a hyperbola. So how many times do you think these guys could intersect? If you just think about a circle and a hyperbola, I think they could intersect not at all. I think they could intersect one time. Let's see. Because look, you've got a circle here, right? So we could intersect not at all. If it's over here. We could intersect one time. We could intersect two times. Or I could even have something like that. And if I were really crazy here, if I did something like this, I guess they could even intersect three times. So I could have 0, 1, 2, 3, or 4 solutions again. All right, so last time we did elimination. We could still do elimination. I think instead what I'm going to do is maybe substitution. Okay, so because I see something that these guys have in common. Do you guys see that? They both have this x plus 5 quantity squared. So I'm going to take this second equation and I'm going to isolate my x plus 5 quantity squared. So I'm going to say y plus 1 is equal to x plus 5 quantity squared. Are you guys okay with that? I took that second equation. So now I'm going to replace, let me get my highlighter. I'm going to replace my x plus 5 quantity squared in the first equation with what I see that it's equal to. Okay, there's going to be my substitution. So let me come back to my pen. So instead of this first equation rewriting x plus 5 quantity squared, I'm going to say y plus 1 plus y minus 2 squared equals 15. Okay, are you guys with me? So here's the substitution. I replaced inside the box up here in the first equation, I replaced with y plus 1. All right, so now I've got a quadratic that I have to solve for. So what I'm going to want to do is expand my y minus 2 quantity squared. Okay, so I'm going to leave that part alone for just a minute. I'm going to expand my y minus 2 times my y minus 2. At some point, I'm going to have to set it equal to 0, but we'll come back to it. All right, so I have y plus 1, plus if I FOIL this out, I have y squared minus 4y plus 4. I'll go ahead and put here minus 15 equals 0. And then I'm just going to kind of make this nice and pretty so I can see if I can't factor it. So I've got, God bless you, I've got a y squared. I have a minus 3y minus 10 equals 0. Let's double check that, make sure I didn't make any mistakes. I've got the 1y squared, y minus 4y is minus 3y, 1 plus 4 is 5, and 5 minus 15 is minus 10. Can I factor this? Yeah, what would my factors be? And positive 2. So I have y equals negative 2 and y equals positive 5. Remember, that's just the y value. I need the corresponding x values now. All right, so which equation do you think might be a little friendlier? I think the second one looks a little friendlier, but you can certainly use the first one. It's just going to take a little bit more work. So if I go up to this first equation, which was y equals x plus 5 quantity squared minus 1. I'm going to replace, I have to do this twice. So I'm going to replace the y with a negative 2, and I'm going to replace the y with a positive 5. All right, and then I'm going to solve each of these for x. All right, I'm going to need to expand those binomials. So I have negative 2 is equal to, so x plus 5 times x plus 5 is x squared plus 10x plus 25. And I still have the negative 1. So kind of the same thing on this side. It's going to be your x squared plus 10x plus 25 minus 1. I need to set the equation equal to 0. So on the left-hand side, I'm going to add 2 to both sides. So I'll have 0 equals x squared plus 10x, 27 plus 26. On the right-hand side, once I subtract 5, I'm going to have x squared plus 10x plus 19. Okay. Factorable? Yeah, sadly, neither of them are factorable. No. How else can we would use the quadratic formula? Aren't you glad you guys learned that? So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, what's 4 times 26? Yeah, so I end up with 100 minus 104. That's a negative 4. So this is not going to give me a real answer. All right, so we're gonna not worry about that one. We're gonna not worry about that one. So 2 of my answers are imaginary, so I'm not gonna worry about the imaginary answers here. If I look at my second one, let's see, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is negative 10 plus or minus 100 minus 36 over 2. So x equals negative 10 plus or minus the square root of 64. Is that right? Is that right? I don't think I got that earlier. Let's double check me real quick. Oh, because it's 19. That's where I made my mistake. That didn't seem right. Yeah, this right here is supposed to be 19, not 9. All right. So what is 19 times 4? 36, 76. And what's 100 minus 76? 24. There we go. That looks like what I had earlier. Am I done with that? No. What can I do? I need to rationalize. This is 4 times 6, so 2 radical 6. Divide each of these pieces by 2. So x is negative 5 plus or minus radical 6. So that's the x coordinate for which y coordinate? For 5. So how many answers do I have here?
2.
I have 2 answers. I have one x value that's negative 5 plus radical 6 comma 5. And I have negative 5 minus radical 6 comma 5. Now you could have written that as the negative 5 plus or minus radical 6 over 5, but I just wanted you to see where I got my 2 answers from. So that's kind of hairy. I don't think that you're going to find a lot of hairy today. I think it'll be a little bit more straightforward. Okay, so we got one more to do, yeah? One more. So let's go back to C, which is your B. No, it's your C. So what is the top equation? A circle, and then under that, an ellipse, right? That's the one that we started here. So these are our possible combinations. I've got the hyperbola and the ellipse. All right, so what do you guys think? You want to do substitution or elimination? I think I'd probably do substitution because I can add the 4y squared here, right? Getting rid of this. And then I have this x squared all by itself. So I can replace this x squared with all of this stuff here. So I would have negative 9 plus 4y squared, that's over 9, plus y squared over 18 equals 1. So this is a rational equation. If I want to solve my rational equation, what would I do? No. No, can't cross multiply unless I have a fraction equals a fraction. So I either need to collapse that, or I'll clear the denominator. So I'm going to multiply this by 18. I'm going to multiply this by 18. And I'm going to multiply this by 18. I know that 9 goes into 18 2 times. I'm just going to put these flipped around. There we go. And then these 18s cancel, plus y squared equals 18. All right, so all I've done here is clear my denominator by multiplying through by 18. I'm going to distribute the 2. 8y squared minus 18 plus y squared equals 18. So I could set this equal to 0. 9y squared, if I subtract 18 from both sides, minus 36 equals 0. Factor out the 9. We have 9 squared minus 4 equals 0. So I have a y plus 2 and a y minus 2. So I have half of my answer. I have something comma negative 2 and something comma positive 2, right? This gives me y equals negative 2. This gives me y equals positive 2. So now I have to go back and decide which equation I want to plug those y values into. Which one looks better to you? The first one, I think you're right. Let me erase the stuff I had up here before. The first one. So I need a y value. I'll start with that positive 2. So if I have x squared minus 4 times 2 squared equals negative 9, I have x squared minus 16 equals negative 9. X squared equals 7, so x equals plus and minus radical 7. And if I plugged in a negative 2, would anything change? Nope. So I've got 2 gives me plus and minus radical 7, plus and minus radical 7, and plus and minus radical 7. So how many answers are there? There's 4. Positive radical 7, negative 2, negative radical 7, negative 2. Positive radical 7, positive 2, negative radical 7, positive 2.